Here Mr. G with another video. This is about Newton's law. It was question 4 from June 2023 done at the Northern Cape and is very much applicable for the grade 12 as well. This question said a 6 kilogram block is placed on a rough horizontal surface. It is connected to a 3 kilogram block with the light in elastic string over a light pulley. The coefficient of kinetic friction between the surface and the 6 kilogram block is 0.2. The 3 kilogram block is pulled downward by a force of 100 Newton, and there you can see the picture. State Newton's second law of motion in words. We're going to write that definitions right here. So Newton's second law in words states that when a net force acts on an object, it accelerates the object in the direction of the net force. But the very first important thing that you will get marked is to say that the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Those are the two marks you are going to get in this specific question. Question 4.2, calculate the magnitude of the acceleration of the two blocks of the system here. Okay, so the first thing we're going to do here is the free body diagram for each of the blocks. So let's going to do on this left hand side here the one for the 6 kilogram blocks. And as usual, we are going to be drawing the axis. So here is the x-axis, and here is the y-axis. Okay, this one is not at scale, doesn't need to be so accurate, but we need to know and have an idea the forces acting there. So the forces acting on these 6 kilogram blocks are the tension to the right, that is T here. The tension to the right. There is frictional force backward. In the opposite direction of motion, the question says there is a coefficient of kinetic friction. There it is. There is a normal force acting on the block, and there is weight acting on that block. Okay, so these are the forces acting on the 6 kilogram block. This is 6 kg. All right, so on this right hand side, we're going to do it for the 3 kg. Once more, we're going to do the two axes, even though this object only is moving in one direction, or only one axis is acting there. This one is the x-axis, perpendicular is the y-axis. And now what we need to know here, the forces acting on that object are going to be, there is the 10 Newton pointing downward. There is 10 Newton. This is applied force pointing downward. There is also going to be tension pointing up or in the opposite direction. This is tension here. And there is also weight, and weight is also pointing down in the same direction as the applied force. This one here is going to be weight for these 3 kilogram blocks. Remember, this is for 3 kg. Alright, so we have the two free body diagrams, so we are going to use in this type of work to calculate acceleration. They want us to work simultaneous. So we're going to go to a new page and we are going to work separated for each block, guys. So we're going to work separated as here, and we're going to apply Newton's second law in each of them. So that is the starting point here. MA. Net force is equal to MA. Net force is equal to MA. Now the object for the 6 kilogram block is moving in the x-axis. So we are going to go back here to the free body diagram and we are going to work in the x-axis. Here, this axis there. This one here. And then for this motion, we're going to take this direction here to the right as positive for this specific block. So what forces are there? Tension and frictional force. So we go back here and we have tension positive minus frictional force equal to mass multiplied by acceleration. All right, so now what is the thing here? We don't have the frictional force, guys. We don't have this friction, so we do have to calculate the frictional force. Remember, frictional force is equal to kinetic coefficient of friction multiplied by normal. And once more, we don't have the normal here in this specific question. It's very simple, but we are going to do it in a proper way. Remember, the purpose is not to solve this question itself, but to learn how to solve the question. So to calculate the normal force, we're going to apply Newton's first law. In the y-axis, because the normal is in the y-axis. So all you have to say is net force is equal to 0. This is Newton's first law. What forces are acting in the y-axis? If you go back here, guys, in the y-axis you have the normal and you have the weight. It's very, very simple. But remember, I'm not teaching you how to solve this specific question, but how to solve any question of Newton's law. So in this case, it's going to be normal minus weight equal to 0. And when you rearrange, normal is equal to weight. In other words, mass multiplied by acceleration due to gravity. If you substitute everything here, you have the normal is equal to 6 multiplied by 9,8, and then the normal is going to be equal to 58,8 Newton. Now, this is the normal force. This normal force, we are going to substitute it there to calculate the friction. So now we have that the frictional force is equal to 0,2, which is the kinetic coefficient of friction, multiplied by the normal, which is 58,8. There we go. So frictional force is going to be equal to 11,76 Newton. That is the frictional force. And once more, you are going to substitute that frictional force there in that specific equation that we have there. So we're going to substitute there everything we have. So tension, we don't have it. Minus frictional force is equal to 11,76 equal to the mass, which is 6 kilograms multiplied by A, which we don't know. And then you can see we have two unknown. We're going to stop right there and we are going to call this one equation 1. All right, so now we cannot go further. We're going to question or to the part of the 3 kilograms block. Now in this case, we only have one axis that have forces, which is the y-axis, and therefore we're going to work with the y-axis. And because the object is moving down, and when I say the object is moving down, I'm referring to the 3 kilogram block. We're going to say down is positive. So the applied force is positive, the weight is positive, and the tension is negative. So if we come to this side here, we have now the applied force positive, we have the weight positive, and we have the tension negative, and everything is equal to MA. All right, we don't have the weight, but the weight is quite simple. You know, the weight is mass times acceleration due to gravity. So if we do that, we say that FA plus mg is very simple, minus T is equal to MA. And then we can substitute everything we have. In this case, the applied force is 10 plus the mass is 3 times, let's do the bracket, we've been using brackets up until now, times 9,8 minus T equal to 3A. And when you solve this one here, you will get that is a 39,4 minus T equal to 3A. And guys, we have here two unknown. We're going to stop this one here and we're going to call this one equation 2. So now we have two equations, equation 1 and equation 2. All we're going to do is to add equation 1 and equation 2. So how am I going to do that? I'm going to say adding 1 plus 2. Okay? So that is what I'm going to do, guys. So I'm going to add everything on the left hand side, which is this one plus that one there. All right? So I say T minus 11,76 plus 39,4 minus T. And all that is equal to, I'm going to add now everything that is on the right hand side. So everything that is on this side, I'm going to add it now, is equal to 6A plus 3 8. And this is simple calculation, guys. Now you can see here two things. You can see that the t's cancel each other. It's t minus t, and you can see that this and this is like terms, and this is like terms. This is simple math now. So we have this on the left hand side, we have that is 27,64, and on this side is 9a. And when you rearrange this one to calculate a, you will get that a is equal to 3,07 meters per second squared. That is the answer for this question of the calculation of the acceleration. I hope you understand it's not that bad, guys. That is the calculation of the acceleration of the block. Now calculate the tension on the string, guys. All we have to do is to use either equation 1 or equation 2. It doesn't really matter which one you use. Let's use equation 2. Now this is question 4.2.2. We are going to use equation 1. It is t minus 11,76 is equal to 6a. And all we're going to do is to substitute the a by the value we got there. Whatever number you get there, you substitute and you will get the marks. So when we do that, we have that is tension minus 11,76 is equal to 6 multiplied by 3,07. And then the rest is simple mathematics. T is equal to 18,42 minus 11,76, and the tension is going to be, okay, here it's not minus, it's a plus, né? So when you do that, the answer is going to be 30,18 Newton. That is the answer for the tension, guys. Very, very simple. So we're almost done with this question. We have only one more to go. They say the question 4.3, how will the acceleration calculated in question 4.2.1 change if the 10 Newton force on the 3 kilogram block is removed from choose from decrease, increase, or remain the same, and give a reason for your answer. And guys, it's very, very easy. If you take off this force here, what is going to happen is that the net force on the 3 kilogram block is less. So the answer is then decrease. Decrease is the answer, and the reason is because the net force on the 3 kg is smaller. And guys, this is the end of the video. I hope you understand. Thank you for watching. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.